Do you know how small the smallest electronic components in the world are? For highly precise products like smartphones, you can't even see them without a microscope. So here's the question: how are these numerous and ultra-tiny components accurately and flawlessly soldered onto the motherboard in large quantities? First, the motherboard is fed into a machine for the solder paste printing process, where a pre-made stencil is placed in the middle of the machine. The holes in the stencil indicate where the solder paste needs to be applied. At this point, lights shine from the top and bottom toward the center, and the machine automatically moves the motherboard forward, backward, left, and right based on the light information to ensure the motherboard is precisely aligned with the holes in the stencil. Once everything is ready, the squeegee moves forward. The solder paste is pushed through the holes in the stencil onto each solder pad on the motherboard. A laser sensor at the front of the machine measures the thickness and diameter of the solder paste. If it detects that there is too little, additional solder paste will be automatically dispensed through this device. The process of spreading the solder paste is very satisfying, and once it's done, the board moves on to the next step: component placement. First, the staff will prepare the component reels in advance and load them into the corresponding feeders according to their specifications. Let's focus on those components that are even smaller than a strand of hair. They enter through this specific inlet, and at this point, it's almost impossible to see them clearly with the naked eye. But the machine's recognition method is truly impressive. These tiny components are scattered onto this transparent tray, and red light is projected upward from the bottom, allowing the machine to detect the position of each component. By setting different modes, we can instruct the machine on which components it should pick up. Once the positions are determined, the machine starts grabbing at an incredible speed. It almost looks like it's flying. If you watch in slow motion, you'll see that every pick is extremely steady. In addition to being fast and precise, this pick and place machine also automatically rescans and recognizes the components after each pick. This ensures that not a single component is picked incorrectly. At the same time, it identifies the placement area and automatically fine-tunes the angle based on the position. When placing the components, it also controls the force very precisely, automatically adjusting the speed for different parts, and then gently and accurately sets them down. It applies precise pressure. This level of skill, even after decades of soldering, would impress even the most experienced craftsmen. If it encounters slightly curved boards, that's not a problem either. The control over force is still spot on. So, with the support of this high-speed placement machine, no matter how small the component is, no matter how many there are, the entire placement process only takes as long as a single song. Next, we move on to the high-temperature soldering stage. In the reflow oven, as the boards travel through this tunnel, the temperature gradually increases toward the end, causing both the pins and the undersides of the chips to melt in an orderly fashion. The entire process goes through temperature ramp-up, sustained peak high temperature, temperature drop, and cooling. There is also another method for pin-type components, which uses wave soldering. The principle is that high-temperature solder is sprayed from the bottom, like a fountain, and the peak of the solder wave just touches the pins. This process is really quite satisfying. From heating, soldering, to cooling, the whole procedure, no matter how many pins there are, whether they're big or small, the efficiency here is unmatched. Not even 100 soldering iron masters could compare. There's also another method. First, the board goes through preheating. Then it slowly passes through a full area wave of solder. Pay attention to the solder absorption. One set flows to the left, the other to the right, ensuring that not a single corner is missed. From this angle, you can see that the contact area is very wide. The whole process is all about comprehensive coverage. Once the whole set is done, the board is fully soldered and successfully comes off the line.